Hi everyone, my name is Dulce. I am a doctoral student and on the occasion of the Brain Awareness Week, I present the poster titled Obesity Modifies Neuronal Morphology in the Hippocampus and Induced Memory Deficits. Obesity is defined as excessive accumulation of adipose tissue. It is caused by an imbalance between calories consumed and calories used. In other words, there is a reduction in physical activity and an increase in food consumption, which causes a positive energy balance. This excess of energy is stored as triglycerides in adipocytes. The metabolic condition associated with obesity represents a risk factor for developing type 2 diabetes mellitus. And several studies have shown that high-fat diets decrease dendritic arborization in many brain regions, including the hippocampus, a crucial region for learning and memory, which is associated with memory deficits and an increased risk of some types of dementia. On the basis of above, the aim of the present study was to analyze the neuronal morphology of the hippocampal trisynaptic circuit in adult male obese sugar rats to determine whether obesity modifies the neurons crucial for spatial learning and memory. To meet this objective, we used 16 rats of the long-Evan strain as the control group and 16 rats of the obese sugar strain as the experimental group. In turn, two groups were formed with 8 rats of each strain. The first group was used to assess spatial learning and memory in the Morris-Burroughs maze, and the second group was used to analyze the dendritic morphology in the hippocampal trisynaptic circuit by Golgi-Cox staining. Our result shows that obese sugar rats maintain high body weights from the beginning up to the end of the experiment compared to long-Evan rats. Also, during the first 2 days, the learning phase, obese rats took longer to locate the platform, and in the memory phase, they made less entries to the quadrant where the platform was located, indicating that they have problems in a bucket acquire information. In other words, obesity is associated with deficits in spatial memory. On the other hand, obese animals had elevated serum levels of glucose, cholesterol, and triglycerides. Regarding dendritic arborization, our results showed that the dendritic length of the neurons in the entorhinal cortex, dendritic iris, and CA3 and CA1 regions of the hippocampus was shorter in obese rats compared to lean rats. And as shown by the representative drawings of the different neurons of the circuit, they present shorter and less branched dendrites. This leads to failures in communication of the neurons and consequently alterations in the capacity of learning and memory in obese subjects. In an try to explain how obesity alters dendritic morphology and spatial memory, it has been proposed on the one hand that leptin signaling deficiency causes deficits in actin synthesis, which leads to damage to the cytoskeleton. On the other hand, microglia reactivity produced by an increase in inflammatory factors exacerbates a synaptic pruning in healthy neurons, which damage the length of the dendrites. And finally, the excess of cholesterol can be affect the integrity of cell membrane of the neurons. In conclusion, obesity represents a serious metabolic disorder that affects the body peripheral systems and also impairs the central nervous system. To put it another way, obesity increases the risk of cognitive impairment. Finally, I will invite you to consult the publication of this work in the Hippocampus Journal with the title Obese Male Sugar Rats Exhibit Dendritic Remodeling in Neurons of the Hippocampal Trisynaptic Circuit as well as Spatial Memory Deficits. Thanks for your attention.